Good morning, dear students. So today we are going to head to the next topic, that is polar representation of complex number. Okay, so as a number, this complex number can be represented in some other form also, that is called the polar form. That is why we are taking polar representation of complex number. Okay, now let us understand what is this actually means. I'm taking a p point xy, okay, that is in the complex plane, that is argand planes we are taking. So z is equal to x plus iy. Let this be a length r. Okay, we are considering this as length. This is o, this is p, op. Okay, and I'm dropping a perpendicular from this point, that is 90 degree, and the angle made by this line or this complex number z is equal to x plus iy be theta. So can you tell me what will be r? R will be under root of, if this is x and this is y, then it will be under root of x square plus y square by Pythagoras theorem, which is nothing but the modulus of your z. Okay, so from here what we understand, that modulus of z gives under root of x square plus y square, which is r, and also with this we can find this theta also, and this theta is called the amplitude or argument of z. What do you mean by the amplitude? In the wave, this is called the amplitude, the maximum displacement. This is called the amplitude. So in the complex plane or in the argand planes, this line r, it subtends some angle, and we say that this is called the amplitude of this particular z, or the argument of this z. Okay, it is written as amplitude of z or argument of z. They both are same at a time. Okay, so from the figure we can say one thing, that if this is angle theta, then what will be your r? R can be written as x cos theta. How we are saying x is equal to r cos theta? How we are saying that? Because we know cos theta is what? Base upon hypotenuse. Base is what? X, hypotenuse is what? R. So x upon r, take r that side, so your x will be r cos theta, and what will be y? Y will be your r sin theta. Okay, by the sine, as sine is what? Perpendicular upon hypotenuse, so perpendicular upon hypotenuse, y upon r, take r that side, so y will be r sin theta. As z is equal to x plus iy, this is the general form of complex number, so put the value of x here. So r cos theta plus I sin theta, I r sin theta, take r common, so cos theta plus I sin theta. This is called the polar form of complex number. What this is called? This is the polar form of complex number. Now you have to remember, now you have to keep in mind some of the conditions of this. As r is always greater than 0, this is the first condition. Second condition, your theta lies between minus pi to plus pi. You have to remember this thing. Your theta lies between minus pi to plus pi. Okay, and one more thing, that the complex number 0 cannot be put into the form this thing, because it does not exist in complex number. Z is equal to, if you put 0 here, so you cannot put in this form 0, because this number, then it will not exist. Okay, because you already have the condition that your r is greater than 0. You know, this is the distance, no? So distance cannot be negative, it should be greater than 0. That is why if you cannot find the value 0 in this particular polar form. Okay, because it does not exist, as I said. Okay, now what all questions we will be going to see in the exercise? We were given with the general form of complex number, that is in terms of z is equal to x plus iy, and you have to change it into z is equal to r bracket cos theta plus I sin theta. Or else you will be asked to find the argument. How you will find the argument? As I told you, x is equal to r cos theta, and y is equal to r sine theta, divide this with this. So y upon x will be r sine theta upon r cos theta, r to r cancelled, sine upon cos is what? 10, tan theta is equal to y upon x. So that is how you will find the argument of the particular thing. Okay, or else you can write from here, take tan that side, so tan inverse y upon x. So theta is equal to tan inverse y upon x can be also the answer. Okay, now you would be thinking that you haven't came across this tan inverse x, so don't worry, just you can write this also, no problem. Okay, we will see that tan inverse and inverse trigonometry in the 12th class. Okay, let us do this question. It says minus root 3 plus I. You need to convert this in the polar form. Okay, so let's begin this. Okay, so let's begin. I'm considering z is equal to minus root 3 plus I, and as we have z is equal to r cos theta plus I sin theta, okay, or r cos theta plus r I sin theta. Now comparing this with this, we are getting r cos theta is equal to minus of root 3 and r sin theta is equal to 1. We see, I will explain you the criteria in this particular question only, and you have to use this criteria in all the questions. Okay, so you understand the criteria very nicely, thoroughly, sincerely, and you can apply in any of the question, you will get the answer. Okay, this 2 we got. Now how to find the value of r? See, cos and sine, they both are related with the square identities. So I'm squaring both the sides, adding both the equations. R square I'm taking common, so cos square plus sine square equal to 3 plus 4. This is 1, so r square equal to 4, r is equal to 2. We'll accept plus 2. Why will not accept minus 2? Because r is greater than 0. We have the condition with us. Okay, what is the another condition? The another condition is theta lies between minus pi to plus pi, or minus 180 to plus 180 degree. Okay, so that means you have to include 180 also, but not minus 180. Okay, now as cos theta will be what? If you put the value of r2, then take 2 in the denominator. Cos theta will be minus root 3 upon 2 and sin theta will be 1 upon 2. Now you have to see that theta so that it should be common for both. When you get cos theta equal to minus root 3 upon 2 and sin theta equal to 1 upon 2 with the same angles, okay, so we have to see that thing. So cos theta equal to minus root 3 upon 2. What is this root 3 upon 2? Is it cos 30 degree? So I have written cos 30 degree. Now how you get minus of cos 30 degree? This is the question. So please try to understand that how I have written minus of cos 30 is cos 180 minus 30. As cos, you don't have to change this cos function. So when your function does not change is 180 plus theta and 360 minus theta. Keep in mind. But here we should not go beyond 180. That means our option 360 plus minus theta will be removed. We only have the option of 180 plus minus theta. So this cos, to make it cos only, I am writing 180 minus, and theta should be here, and as you solve this one, you will get minus of cos 30. See, cos 180 minus 30. 180 minus theta falls in which quadrant? Second quadrant. Second quadrant, sine and cosec are only positive. So that is why the negative. So negative of cos 30, I am writing it as cos 180 minus theta. If you solve this one, you will get this. So from here to here also we can go, no? So 180 minus 30, what will be the solution of this? Cos 150. Cos theta is equal to cos 150. Theta is equal to 150. Here if you see sin theta is equal to 1 upon 2, you get 1 upon 2 at sin 150 also. So sin theta equal to 150, theta equal to, they both are satisfying, theta equal to 150. So your final answer will be, your final angle will be that angle which will be accepted and satisfied by both cos and sine. Okay, it should not be different, it should be the same. Now finally you are done with all the things. Put here, so z is equal to r cos theta plus I sin theta. So z is equal to 2 bracket cos 5 pi by 6 plus I sin 5 pi by 6. 5 pi by 6, 150 or 5 pi by 6. So that is how you have to do in each and every question. So let me just give you a quick that means algorithm of solving the question. First of all, you write this thing, detect r cos theta, r sin theta, square it, add it, then you will get the value of r. Okay, then you put here in the value cos theta sin theta and you solve for the theta. You get r and theta value and just you need to put it. Remembering the two most important conditions. First one is r is greater than 0 and your theta lies between minus pi to pi. If you remember this criteria, you can easily solve any of the question. Okay. Okay. Now if you have a question that 3 cos 3 pi by 2 plus I sin 3 pi by 2. This is already in the polar form. You have to find it in the general form. So it's easy, I think. Put the value of cos 3 pi by 2 here, sin 3 pi by 2. Multiply this 3 inside, you will get the answer. Use the calculator for finding the values of these two, or else if you know, then you can directly write. Okay. Okay, so let us understand this question. You have to find modulus and amplitude of this question. So multiply 2 inside first. Okay, so what will be z? Modulus of z, if I consider z is equal to this, so under root of minus 2 square plus 2 root 3 the whole square. This will be 4 and the answer of this is 12. 4 plus 12, 16. Your modulus of z is 4. Now you need to find the amplitude. As I explained you how to find amplitude, tan theta is equal to y upon x. You directly do tan theta is equal to y upon x. So tan theta is equal to, what is your y? 2 root 3. What is your x? Minus of 2. 2 with this 2 cancel. So tan theta is equal to minus of root 3. Now what is root 3? Tan 60 degree. Tan is equal to minus tan 60 degree. Now we cannot equate here because they both are not same. So what we do, just see how did you get minus of tan 60 degree. Remember, tan should be tan only. So tan should be tan. So either two options, 180 plus minus theta, 360 plus minus theta. We cannot go with 360 plus minus theta as it is not lying in our condition minus pi to plus pi. We'll take 180 plus minus theta. Now 180 plus theta is in the 10 quadrant. That means tan function, that is positive, but we need the negative. So the last option is only 180 minus theta. So tan 180 minus 60 will give you minus of tan 60 degree. Okay. So that is how 180 minus 60 becomes the 120. Theta is equal to 120. Or if you want to write this in pi, you can easily do that. 120 into pi by 180 like that. Okay, so I expect that you'll do such type of question. First of all, go through the examples. Whatever I guess I have explained you only the one question of converting from general form to polar form. You know, if you follow that question, you can do any question. Still, we'll take some more question in the next video. We'll understand, don't worry. But you try from your end that how much you can do. So I hope and I expect that you will do it. Okay. So here we end. Thank you so much. Have a nice day.